All right, everybody, here are I'd say maybe the second part two of the 9-1, 9-2 notes. Um, the 9-1 and 9-2 are basically kind of the same chapter. It's just, you're adding a little something onto it. But so now let's take all the stuff we've been doing. We're adding a little bit of stuff for domain and range, and let's go ahead and graph it out as well. All right, now there's a little trick to graphing these that you'll see is actually fairly simple. Actually, it makes it graphing, makes it filling out the table a little, it makes filling out the table, pretty quick actually. So let's go ahead and start it out. So it opens up and down. Once again, I'm looking at, I got my A value, my B, and my C. I'm looking at my A value, the number out front. It is positive, so I know it's going to open up. And if it opens up, it's got a min. All right, so I already know it's going to open up. It's going to have a min value. Let's find the axis of symmetry. Once again, I got my formula right here, negative b over 2a. Plug in negative b, negative 16, negative, that was turn to positive, over 2 times a, which is 2. I'm going to have 16 over 4. 16 divided by 4, that's just going to get me 4. So my axis of symmetry is 4. Vertex, that means the vertex x value is 4, so I'm going to go ahead and plug the 4 in for x to get the rest of the value. So 2 times 4 squared minus 16 times 4 plus 24. Let's see, 16 times 4 is negative 60. Oh, crud. That's going to get me negative 64. 4 squared is 16 plus 2 says 32. Plus 24, negative 32 minus is negative 32. Plus 24, that gets me negative 8. So I know the vertex is going to be 4 and negative 8. Now, in my table, I'm going to put 4 and negative 8 right in the middle here. I'm going to put it right smack dab in the center. All right? So now the y-intercept, so let's fill the rest of it out. Y-intercept, just my C value, 24. 0, 24. Okay? And domain and range. Actually, I'll do domain now. Yeah, domain and range we'll do now. So domain is always negative infinity to infinity. That means I can plug, domain basically means I can plug in any number for x that I want to plug in. But for all intents and purposes, domain is negative infinity to infinity here. Now the range. Now you got to ask yourself one question. Does this open up or does it open down? This opens up, so I know that it's going to go up to positive infinity. That goes on the right side. Again, left side is negative infinity, right side is positive infinity. So on the right side, I'm going to write an infinity. Then over here, whatever the other's position is going to be my y value of my vertex. So it's going to be negative 8, and then there's going to be a bracket that goes there. It's going to be, make sure if you have a number, you have a bracket that goes there. Okay. Okay. So now we've gotten all this stuff over here figured out. Now let's figure out the rest of the table. So for the x values, you're going to go 1 up, 2 up, so 2 and 3 from the vertex. And then you're going to go the other way, 5 and 6. So you're going to go 3 and 2, 5 and 6, okay? Now the great thing about this is that you're going to see you only have to plug in like only 1/2 of the numbers. I'll explain. Let's plug this 3 in here, all right? So I'm going to plug 2. 3 squared minus 16 times 3 plus 24. If we work all this out, 3 squared is 9, so that's going to give me 18 minus 16 times 3 is going to give me 48 plus 24. That gets me negative 30 plus 24, which is negative 6. So the negative 6 goes here. The great way about how I did this right here is that if the 3 is negative 6, the 1 right here has to be negative 6. And that also works out to where if this one right here, these two right here are going to be the exact same. All right. So all I have to do is plug in the 2. I have to find this number here. That'll get me this number down here. So let's go ahead and do that. All right. Oh, let me go back here. So plug in 2 for x. 2 times 2 squared minus 16 times 2 plus 24. 2 squared is 4 times 2. That gets me 8 minus, that'll be 32 plus 24. 8 minus 32 is negative 24, I believe. Plus 24, that gets me 0, all right? So what that tells me is that that 0 is going to be right here as well, all right? And that works every single time, all right? If you put the vertex in the middle here, you go 1, 2 up, 1, 2 down. It'll work every time. Now let's go ahead and graph it. I'll do 4, negative 8. That goes right here. 6 and 0, 2 and 0, 3 and negative 6, and then 5 and negative 6. And it'll look something like that. All right? All right. Let's do another example here. All right? Graph the equation. Negative x squared minus 2x minus 1. The negative, that means it's going to open down, which means it's going to have a max value. All right? It's going to look something like that. Axis of symmetry. Let's go ahead and plug this in. Negative b. Negative of negative 2. My b value is negative 2. Negative of negative 2 is going to give me positive 2 over 2 times negative 1. A value is negative 1. It's going to be 2 over negative 2. That means x equals negative 1. The negative 1 goes here. Find the rest of it. I need to plug in negative 1 for x. So I'll do negative 1 squared minus 2 times negative 1 minus 1. Negative 1 squared, that's just 1. Put the negative in front. That's going to be minus 1. Negative 2 times negative 1 gives me plus 2 minus 1. Let's see. 1 plus 2 is 1 minus 1. So that'll be negative 1, 0. So I'll put that one right in the middle here. All right. My y-intercept is the c value. This one right here. So my y-intercept is going to be negative 1. All right. Or I'm also going to write out 0, negative 1. Domain. Negative infinity to infinity. That means I can plug any number I want in for x. Range. It opens down. So I'm going to start with a negative infinity. Remember, negative infinity always goes on the left side. Comma. And then I put the y value of my vertex, which is 0, with a bracket. All right? Okay. So now, let's fill out the x values. I'm going to go 1, 2 up from negative 1, 0 to 1. I'm going to go 2 down, negative 2 and negative 3. And the wonderful thing about this is that I already know the y value of this 0. It's my y-intercept. Because if I plug in 0 for x, that's the same as finding my y-intercept. So if you have 0 for x, you know that that's already the same as your y-intercept. If you want to check it, plug in 0. These are going to cancel out. You're going to be left with negative 1. So what that tells me is that this one right here is going to be negative 1. All right? So all I have to do now is just plug in the rest of the numbers and see what I get. So I'm going to plug in the 1. I'm going to plug in the 1 up there. All right? So I'm plugging 1 for x. Minus 2 times 1, minus 1. This right here will give me negative 1. Negative 2 times 1 would be negative 2, minus 1. We add all that together, it should get negative 4. And again, that means that this one right here will also be negative 4 as well. Okay? Alrighty, so now let's go ahead and graph this. Put these on the graph. Go negative 1, 0. Well, that just stays right there. 0, negative 1. That's going to go right here. 1, negative 4, so I'll go 1, then down to 4, right about there. Negative 2, 1 right here, and then negative 3, should be negative 4, excuse me. Negative 3, negative 4. And there you go. All right. Do another one here, all right? Actually, let's go to this one, all right? Now, the only reason I really skipped this last one, I want to get to the solutions here, all right? I want to hit that example up. All right, good. Okay, so we're going to do basically the same exact thing that we just did for the last two. The only difference with this one is now we have to add in solutions, and we'll get to that when we get there. I'm going to kind of skip over that. So, opens up or down. There's this negative out front here. My a value is negative 1, so I know that it's going to open down, which means if it opens down, it's a max value, okay? Axis of symmetry, negative b over 2a. My b value is negative 4. Negative of that is going to be positive 4 over 2 times negative 1. That's going to give me 4 over negative 2, which is going to be negative 2. So the axis of symmetry is x equals negative 2. vertex. I'm actually going to write the vertex in here. Actually, no, right here. -2 there. Find the y value. I'm going to plug in -2. So negative of -2 squared minus 4 times -2 plus 5. I'm going to do the squared first here. Don't do the negative. Do the squared first. -2 squared is 4. Put the negative out front. That just turns into -4 plus 8 plus 5. So it turns into 4 plus 5, which is 9. So it's going to be -2, 9. We're going to put that there, okay? All right. Y-intercept, that's going to be the 5. So that's going to be my C value. So the y-intercept is 5 or 0, 5. Kind of separate some stuff out here. Solutions I'm going to skip. Domain, -infinity to infinity. For every problem, I can plug any number I want in for x. For range, I open down. So I'm going to start with -infinity first. -infinity always goes first there on the left side. Comma, y value of the vertex, 9, with a bracket. Let me go back here. I put a bracket there. Good. I had to make sure of myself. Okay. Okay, so now we got all this stuff. Now let's figure out some other things here. So I'm going to do 2 up. So -1, 0, -3, -4. Do you know what this value right here is going to be? Yes, it's going to be 5 because I plug in 0 for x. It's my y-intercept, so it's going to be the 5, which means this one right here is going to be 5. I'm going to plug in -1. Figure that one out. I'll do that one up here. So negative of -1 squared minus 4 times -1 plus 5. This right here is going to be -1 plus 4 plus 5. That's going to get me, well, let's see. It's going to get me 8. So this one right here is going to be 8, okay? Now, I'm not going to graph them I'll graph the points here, all right? We still need to figure out those solutions, but let's graph the points here. So -2, 9, so that's going to go up here. 0, 5, that's going to be around here. And then -4, 5, that's going to be right around there. -1, 8, so -1 to 8. -3 to 8, okay? Alrighty, so we got those graphed. I'm not going to connect the lines just yet because we still have to deal with these solutions, okay? Now, solutions, once again, are the x-intercepts. Well, I don't really have any of these points that are intercepting the x value, so what I'm going to do, let's just go up. Let's go up 1 and go back down 1, okay? And let's see if I plug these in, I'll get 0, because what I'm wanting to do is I'm wanting to get a 0 in the y column here, all right? That's what I'm looking for. So let's plug in 1, all right? I'm going to go ahead and erase some stuff here. So -1 squared minus 4 times 1 plus 5. It's going to be -1 minus 4 plus 5. Well, shoot, if we add those together, I get myself 0, which means, again, it still follows the same rules. This one is going to be 0 as well. So we'll go 1, 0, which is going to be here, -5, 0, which is going to be there. Connect the dots. And not really connected, but that should be right about there, okay? Alrighty, so now I have 0 in my y column twice. My x values attached to them are just going to be 1 and -5. So my solutions are going to be 1, -5, okay? Alrighty. And then so again, if you look at your x-axis, x-intercepts. You got 1 at 1, 1 at -5, all right? So that's what we're looking for with solutions. You're either looking for x-intercepts or you're looking for a y value to be 0. And if the y value is 0, you just look at what the x value is, and that's your solution, all right? Alrighty, and shoot, let's actually go back and check some more of these out. Well, shoot, if we look at this one, solutions, this value right here crosses, it kind of touches, but it still technically crosses at -1. And if I look at my y values, 0, -1. So my solutions here would be -1. Let's check out this one. 0, 2. So 2 and 6. Solutions here. 2 and 6.